Okay, in this video we've got a block here and a block B, and we've got a particle extended by a string of 0.13 in the top and an elastic string of 0.13 at the bottom. But because it is elastic, then the weight, the mass, will extend the string a little bit, extend the string a little bit. And what we've got to try to find is, if we release the particle, which we can do, is what will be the lower length here of the lower string and what will be the higher length. Okay, at the moment we can see it will be 0.12 and that here it will be 0.02. If we click here, we get the original position. Okay, so just going to reset that a little bit so you can just have a look. Let's get rid of that for a minute. Okay, so if you release it for those particular settings, you will get that. Okay, and then here, if you click here, you get the mathematics for the model. Okay, so we will see, for example, T1, if we resolve it, is T2 plus the mass, so it's T1 is equal to T2 plus 0.5 g. Hooke's law, according to Hooke's law, T1 will be lambda x1 times the natural length of the string. Don't forget the string is elastic, okay? And lambda represents the modulus of elasticity, 0.13, okay? And then T2 will be lambda x2 over 0.13. Okay, if we now substitute those into one, we get that. Okay, if we multiply this by 0.13 and subtract that, we get this, and then if we divide by lambda, we get x1 minus x2 is equal to this. And therefore, if we also know that x2 plus x1 must become equal to 0.4 minus 0.13 minus 0.13, which is 0.14. Okay, if we add these two together, we are going to get that 2x1 will be equal to that, and that will allow me to calculate x1. If we subtract them, then that will allow me to calculate x2, taking g to be 9.8 as for MEI maths. Okay, now if x2 is greater than 0, then the lower part will not be slack from 6. So in order for it not to be slack, okay, if we take 6, okay, 6 has to be greater than 0. Okay, and then we're going to get 0.13 g is less than 0.07. There's an extra a there, which we'll get rid of later. And we're going to get that lambda must be greater than 0.13 g over 0.07. Therefore, lambda will be greater than 4.55 newtons. So if we move the modulus of elasticity lambda to less than that value, you will notice that x2 becomes negative warning. It says warning there. The lower part of the string will be slack. Okay, if we try to get it there, it will be just at that point. It will change back to being okay again. Okay, so this has been a video to show you about a particle suspended between on two bits of elastic string. Okay, and then suddenly being released. Okay, I hope you've understood. GeoGebra app will be in the notes of the video, and I thank you very much for watching.